Greetings, Bizarro here with test subjects, and as you can see, I'm in kind of a different space because this is a different kind of video than what you're used to us doing. We've been working behind the scenes with a bunch of different escape rooms to help them kind of understand and troubleshoot their tech. So we thought we'd take some of these things that we have shown them and show it to you in this brand new video series that we are going to call Tech Tips. In this series, we're going to go over things that I've seen people consistently having issues with. And that includes certain types of software, how to wire up controllers that you'll find in an escape room, as well as common issues that people have with certain types of tech. In this first video, we're going to go over how to pinpoint and troubleshoot the failure points in a chain. And that is going to be using some stuff that you probably have in your escape room already, and that is a power supply, a relay module, LEDs, and the dreaded reed switch. Ooh. Anyway, so we're going to go down to the table and see how you can try to find out where your fail points lie and how to isolate where your issues are when you're having them. So here's what I consider a very basic puzzle setup right here. This is a 12-volt power source that is splitting off and is powering the relay module and the LED right here. And we have a reed switch that is being used as trigger voltage right here. And when I turn this on, it powers this up. And when I put a magnet to this, it turns on the LED, and you can hear the relay module clicking, hopefully. So what I've found is some people, when something like this fails, they don't seem to understand how to isolate the problem. And that's kind of what we're going to go over here today. This basic setup is kind of how most things are. You have cause and effect. You have your cause, which is the magnet and the reed switch. You have your effect, which is the LED. So what I find is when you need to troubleshoot something like this, you have to test each component individually to find the fail point. That's really the easiest thing that I can say. So let's take all this apart, so you can kind of see what I'm talking about. Let's say we wanted to test the LED first, all right? So one thing you could do is you could hook this up to power like I have here. You could take a power source. That's why I like to use these little blue batteries, these guys here, because these let me go around an escape room and try to test different things at different intervals. So I'm going to take these. I would highly recommend having these things, these terminals laying around, because they really help speed things up. If you need to swap out a component and everything is hooked to these plugs or these pigtails like this, it's very easy to swap these things out. So these are probably easier than these, but if you have either one, it's just good to be able to hot swap them. So I'm going to turn the power on. Yep, all right. So I know the LED works. So that means the fail point would not have been in the LED. So we put that to the side. Now, a lot of times I see the issue is actually power. People aren't running enough power through their stuff. I like to use these 12-volt 5-amp power supplies here because I know that they will supply enough power, and you can always have more amperage. You need to have the same voltage, but you should always have more. You should usually have a little more amperage than is called for, but let's say you have something that's using 1 amp and you throw a 10-amp power supply on this, it won't affect it. As long as the voltage is the same, you'll be fine. And the 5-amp, these blocks here, I find just pretty much can supply enough power to most anything that you're going to need to supply power to. So that's individual puzzles, obviously. You can get those big control boxes that are used for closed-circuit TVs and things like that, and those supply power in a different way. But that's a whole other situation. So how do you test a bad power supply? Well, you get a multimeter. This is just a multimeter from Walmart. It's a nice cheap little guy here that we had to kind of get last minute, and it works fine. To use a multimeter, generally what you're going to do, since you're dealing with DC voltage, you're going to have these numbers here. You're going to see it'll either say DC or it'll intimate something is DC versus AC. Obviously, read the instructions, read the manual just in case. But anyway, so over here is the DC side, and you want to put it as close to the lowest voltage you're at. So since we're doing 12 volts, I'm going to put it to 20. 200 would be too much, 2 would be too little. So 20 is where you want to go. So usually the center of these is positive. Not always. You want to check that, but if I put this here and I turn it on, excuse me, what will happen is this will tell me that I'm getting 10.89 volts. Now that's because I haven't charged this thing in a while, but if you had something like this plugged in, you would be getting probably around 12 12.3 to 12.6. There's always a little more here and there. So this one's running a little low, but in this situation it doesn't matter. So I know that this one is working because it's getting the voltage that I expect it to be getting. If it was plugged in, it would be getting 12. So that I know is working. So I can kind of set this off to the side. What about the reed switch? Is the reed switch the fail point? Let's find out. So in this situation, what I would do is I would hook up this reed switch to an LED. Now, I highly recommend you get some of these alligator clip wires here, these things. These come in very handy. So what I'm going to do is I'm going to clip one end to this, like that. And this is connected to the positive rail, by the way. Usually when you have a switch, you want to wire the switch into the positive, in between the positive wires, right? So what I'm going to do is I'm going to have the reed switch. The reed switch doesn't have a polarity. It doesn't matter which end is which. So I hook this, and now this goes to here. You can see that this is going red. Let me stretch this out for you here. Red goes to the reed switch, continues out of the reed switch to the red right here, right? Now, the negative, or ground, just goes to the ground on this. So this just runs to this part right here. Now I would plug this into a power source like this, and I would test the reed switch this way as soon as I turn the battery on. Yep, okay, so the reed switch works. So that's not my fail point. Huh, interesting, okay. So the last thing would be to test the relay module here and see if it's bad. Now, usually you want to have extra things on hand because then you can just test it with new components where you need them to. But in this situation, now I don't need to hook the LED back up to this to know if it works or not because it will just click when I want it to. So generally, the best way to test these is to hook them up to power, and the first step is to turn it on and see if usually they'll have LEDs. Not all of them have LEDs, power LEDs on them, all right? So be aware in the specs if yours has a power LED. Sometimes they only have LEDs when they are activated. How do you tell when they're activated? Well, since this one has a jumper set for low, some of these newer ones have a high and low function, and I have this one set to low. So that means that you're in here, this says in on it, and that means that low means you're going to connect your switch or whatever from the in, which is also signal, to your ground or your negative. So to test if this is working, I would take a jumper wire, attach it to this screw, and then I would touch it to this screw right here, and if it clicks, okay, so now that LED is coming on, and it's clicking, so that means that is working, right? Now, if I was to have tested all these components separately and found that everything is working, that's when I start to check my connections. Because sometimes these screw terminals, sometimes a wire is just not in there correctly. Sometimes somehow it has gotten around the screw, or let's say, what I like to do is I like to attach wires to make sure they're secure. What I will do is I will fold the piece of wire back onto the housing like this, and I'll stuff that in there. This way it's gripping both of them. But let's say something has happened where for some reason the wire has gotten underneath the screw and it's just making no contact. Or what I've had happen before is the wire has just gone too deep inside and it's bypassing the screw itself. So that would be the last thing I would test, would be to check my connections, unscrew everything, and then reseat them. Now you can kind of skip all this if you use ferrules. Ferrules? I don't know how to pronounce it, but they're basically things that, what's the word I'm looking for here? Guarantee that they will make a connection. I believe in some countries they are mandatory for certain things, but not here. So you can get those, or you can just troubleshoot your connections like that. And once you have troubleshooted everything, if everything works independently, then that means, and this works independently, that's when you start getting very frustrated. and sometimes it's something so easy and so basic you just don't realize it. And sometimes there is a break in a wire, like if you're running a wire through a wall, you'll end up having, for some reason, somebody has screwed something into the wall and punctured the wire. And so your fail point is in somewhere you can't test. But you can test those wires. So if a wire is running through a wall, you would hook up one of these power supplies here to that end of the wire, and then you would hook up an LED to the end of the wire using these alligator clips, and then you run power through it. So then if the light doesn't turn on, then you know that the wire is an issue. You can also get continuity testers and line tracers and things like that. But personally, I like the visualness of this because it's just, I know for a fact that it's working. So that is really the basics of troubleshooting your circuits and your puzzles, is just finding the fail points. So there you go. That's our first tech tips video there for you. Just remember, you don't want to look at the thing as a whole. You want to look at it as individual pieces. That's really all there is to it. Don't be overwhelmed by everything at once. Just break it down to its individual components, and in no time you'll be able to figure out what's going on with your tech. Stay tuned for future episodes where we're going to be going over individual components, like all these different types of relays that are on the market that we tend to use, RFIDs, and different types of power supplies and controllers and things like that. So if you have any questions, feel free to comment. And if you want us to go over any particular item that you're having issue with, let us know and we'll see what we can do about it. So see you next time on Tech Tips.